Good afternoon, everybody. I welcome you to the seventh section of the first International FibEnTech Congress. In this section, we will have, first of all, a talk from our invited speaker, Andrzej Bialowiec, followed by three research work presentations. The first video is from Andrzej Bialowiec, which is a full professor and senior researcher of the Wrocław University of Environmental and Life Science, having research interests on organic waste valorization and wastewater treatment and reuse through constructed wetlands technology. Professor Andrzej Bialowiec has a large experience on research on waste valorization, and he has been working in several countries and different research centers, including in UBI, where he has been stayed for several times working in research projects associated with wetland technology. This talk, or this video, will have 30 minutes talk, and afterwards we'll have three presentations of young researchers that will have presentations on the area of waste valorization and groundwater protection. So the second video will be from Andres Tudor, that will present the work on chemical and mineralogical characterization of biomass ash from soil reinforcement and liner material. The second one will be a work of Leonardo Marchiori on geotechnical characterization of biomass ash from soil reinforcement and liner materials. And finally, we'll have Vanessa Gonçalves that will present the work on the evaluation of Entre Rios thermal aquifer vulnerability using the drastic index. After the last video, we'll have 15 minutes of discussion. So we'll back to this point, and we'll have this discussion with the three last researchers. So have a nice session, and we'll start with the first video.
Good afternoon. My name is Andrzej Bialowiec. I work at the Wrocław University of Environmental and Life Sciences, and it's a great honor and opportunity for me to participate in the conference and to give a speech titled Sustainable Waste Management, and I'm going to talk about the new approaches. So, as I mentioned, I work for the Wrocław of Environmental and Life Sciences. Here I am a leader of the waste of group, which is called Waste and Biomass Valorization Group. And here we have a cloud showing the keywords describing our group activity. So, as you see, we deal mostly with waste management, with some waste to energy, waste to carbon approaches, and we try to develop new technologies related to waste valorization into biochar, for example. So starting from the beginning, actually, so the main definition of the sustainable development is that kind of development which meets the needs of the current generations without compromising the ability of future generation to meet their own needs. 17 goals of sustainable development has been defined, and I think that the goal which is the most closely related to our presentation, so responsible consumption and production. Actually, it defines a very high level of environmental protection. Also, it provides the new approach to circular economy and even goes a little bit further. So it also is related to the new approach of bioeconomy. Regarding the circular economy, actually, this is kind of European policy. The European Commission adopted a circular economy package, which includes measures that will help stimulate Europe's transition towards a circular economy, boost global competitiveness, foster sustainable economic growth, and generate new jobs. So it is a kind of action plan for the circular economy that establish a concrete and ambitious program of action which measures covering the whole cycle, like circular economy, the whole cycle from production and consumption to waste management, and the market for the secondary raw materials, and revised legislative proposals on waste. So actually the proposed actions will contribute to closing the loop of products life cycle to greater recycling and reuse, and bring benefits for both the environment and the economy. Of circular economy may be a kind of modern economic concept aimed at rational use of resources and reducing the negative environmental impact of manufactured products. According to this concept, products, materials, and raw materials should remain in the economy as long as possible, and the generation of waste should be minimized as much as it is possible. And further on during the presentation, so we will see what kind of new approaches can be derived from this circular economy concept. So let's go to the waste management, so waste definition. So here I would like to present the two different approaches to waste definition. So here in European Union, actually in our legislation we have Waste Framework Directive. In US, you may see that we have a Resource Conservation and Recovery Act. So in their name of their directive, actually, they don't use word waste, right? They consider all of the waste as a resource. So Resource Conservation and Recovery Act. So I think that is the message from the title of this legislative act is more positive, and they see that waste can be kind of resource. Here in Europe, actually, we consider waste as a problem which should be solved. Kind of definition of waste we have. So actually in Europe, so waste means any substance or object which the holder discards or intends to discard or is required to discard. So we have three situations. First one is when we decide to throw something out. The second one is mostly related with the industry. Before the investment, we should obtain the environmental impact assessment decision. And so actually before we start new business activity, new industrial activity, so we should define how many waste we are going to produce and what we are going to do with them. So this is the second situation, and the third situation actually is related mostly with the food waste. For example, if the validity of the food waste it cannot be prolonged anymore, so actually we are obliged to treat this food waste as a waste and treat them in proper way. Right, so we may define the municipal solid waste, so which we produce every day in our homes. So we have industrial waste, actually, which the volume or amount of the industrial waste is about tenfold higher than municipal solid waste. So we have also different types of industrial waste from mining, energy production, food production, petroleum, cement sector, chemical, paper production. So we have different sources of industrial waste. Also, we may define the medical waste, construction waste. Also, there is a waste of electric and electronic equipment, which the amount of this waste is growing very gradually. Also, we may define the waste from waste and wastewater treatment, right? So when we have the incineration plant of waste, so we may consider produced waste due to the incineration. So we may have fly ash or bottom ash, or we may define also some sewage sludge from the wastewater treatment plant. Also, we may define hazardous waste and many other types. So what is the waste management? According to European definition, waste management means the collection, transport, recovery, and disposal of waste, including the supervision of each operation and aftercare of disposal sites like landfills, and including actions taken as a dealer or broker. So, so here we may have some elements of the waste management like collection, transport, recovery, and disposal of waste. And also we should monitor all of these processes. So we should supervise all of the procedures. Shape of the waste management system, you may see how many elements and how many aspects can be touched by the waste management. So here at the beginning, so here we have goods and services. So we have a market for goods and services, and people, they do consumption, and we produce waste, right? And those waste we may produce, we may collect them, right? We may transport them, so we have some logistical aspects, and we have treatment, different types of treatment, including recovery, energy recovery, reusing or recycling, and also disposal by landfilling or incineration, for example. And during all of these processes, right, so we may have different aspects related to the costs of particular actions, like cost of transportation, cost of collection, cost of bins. So we have economy aspects. We have also aspects related to environmental protection, right? We may have some emissions of odors. We may have some discharging of pollutants during the treatment. So we should think globally on the waste management, and we should consider all of these aspects related with the system. Yes, so we shouldn't neglect any important factors, because the waste management is actually something good, which helps to keep the environmental clean. However, waste management itself may also be a source of the pollution. Therefore, we should keep we should keep all of these aspects in mind, and we shouldn't emit the pollutions. Going further to the description of whole elements, so we should have the waste collection, right? So it means that the gathering of waste, including the preliminary sorting and preliminary storage of waste for the purposes of transport to the waste treatment facility. And also you very well know that we may have the separate collection, which is getting more popular in Europe. So means the collection where waste stream is kept separately by type and nature, so as to facilitate a specific treatment. So waste which are collected separately are much easier and much better treatable due to recycling, for example. Waste prevention, right? So we have it means measures taken before the substance, material, or products has become a waste. So before the decision, right? Because we want to minimize the production of waste in the matter of the quantity of waste, including through the reuse of products or the extension of the lifespan of products, to adverse impacts of the generated waste and environment and human health. And the content of harmful substances in the material and products also should be minimized. We may have such kind of approach for the preparing for the reuse. So it meaning checking, cleaning, or repairing recovery operations by which products or components of products that have become waste are prepared so that they can be reused without any other pre-processing. We have reusing. It means any operation by which products or components that are not waste are used again for the same purpose for which they were conceived. So any operation, the principal result of which is waste serving a useful purpose by replacing other materials which would otherwise have been used to fulfill a particular function, or waste being prepared to fulfill that function in the plant or in the wider economy. So good example of the recovery might be production of the refuse-derived fuel from waste, and using this fuel instead of coal in the cement plant, for example. So in this way we replace or we substitute the coal fossil fuel. We have the recycling. I think that one of the most important approaches in sustainable waste management. So it means any recovery operation by which waste materials are reprocessed into products, materials, or substances, whether for the original or other purposes. It includes the reprocessing of organic material, but does not include energy recovery. This is important from the European point of view, because we don't consider the concept waste to energy as a recycling. And the reprocessing into materials that are to be used as a fuel for or for backfilling operations. So we may have also different types of recycling. We may have the material recycling. So it means that if we have a plastic, for example, so we may clean these plastic bottles, we may shred, and we may reuse it again for the production of bottles. Also, we may have the chemical recycling. Usually for the chemical recycling, some thermochemical processes are used, like pyrolysis or gasification. And those processes lead to the production of the monomers of plastics, for example. And we may derive the liquid fraction, very similar to oil. And this liquid fraction can be reused or recycled in the petrochemical industry. Final disposal, so it means that we may landfill our waste or we may incinerate our waste. So here we have two pictures showing inappropriate way of the waste disposal. So here we have the very old landfill site, and also we have the fire of the organic waste storage place. So we should avoid that kind of actions. Therefore, we have special regulation how the landfill sites or the incineration plant should be designed and operated. So we have some challenges in European Union, right? Because we have this policy no waste landfilling, right? We have the increase of recycling efficiency. We should develop the circular economy approach, and here also we have the zero waste approach. And actually the year 2020 was a kind of threshold year when we should obtain very rigorous levels of recycling, for example, because we agreed to have the 50% level of the recycling of paper, metal, plastics, and glass. Yes, in some countries that level has been achieved, in some hasn't. More ambitious goals in European Union. By 2030, actually, we should achieve 65% of municipal solid waste recycling. We should have 75% of the packages recycling. We should landfill only 10% of municipal solid waste. And also there will be ban for the packages landfilling. However, by 2050, very ambitious goals to implement circular economy in which nothing is wasted. So it means we should develop and implement the concept of zero waste. It's so important, right? Because every day for example, every day we eat meals, every day we drink drinks, and after the consumption, actually, we decide to throw the residuals out to the bins, and actually, the things or materials which we are throwing out, actually, they have value. They have value. So it means that somehow we throw out our money, yeah, because when we did our shopping, actually, we paid for these materials. And when we decide to throw it out, actually we throw the money. So it means that actually there is a market for that kind of materials, and this market has a great value. But also you and other people, they are doing the same. So every day, everybody throws away the waste on the massive scale. So aware that all of the goods which we buy, actually we consume that goods, and it means that the consumption actually can be defined from the waste management point of view. It's a kind of transformation of products into waste. All right, so this is the kind of definition of which is consumption. Probably different than from the economical point of view. However, this definition is very, very short and very precise. Actually, we know that the economy development leads to the increase of the waste production. And according to research of Organization of Economic Cooperation and Development, they found out that the increase in national income by 1% increases the amount of municipal waste by almost 0.7%. And also some data from World Bank states that by 2025 the volume of waste will increase by 2.2 billion tons a year worldwide. So it means that the development of the economy will bring the increase in the waste production. Therefore, we should look for the new solutions, for the new technologies, new policies, new approaches, how to minimize the waste production, and also how to treat this waste as a resource, and how to recycle, reuse, recover the properties and the materials contained in waste. The traditional system of waste management has a linear character. So it means that when we decide to buy something, we consume, then we throw it out the bin, then we have a system of transportation, truck takes the waste to the treatment facility. And actually everything is linear. There is no closing the loop. There is, of course, solution for that, how to improve the waste treatment. First of all, we should actually divide our look on the waste management. First aspect is an economic concern. Actually, we are aware that waste management costs, right? So we should have money, and people should pay for their waste, right? So it's a kind of obvious that the producers of waste should be responsible for the payment, and some producers of goods also may be somehow responsible for the payment or participation in this market. So this market actually is growing, right? And we know all of these aspects of this growing market of waste management. Yes, because we have the experience. We develop our waste management system since many decades. So actually we have tools for the proper waste management. And also we have the environmental concern in the waste management system construction, right? Because we are aware that if we don't treat our waste properly, so we will have a polluted environment. And we may have contact with some even hazardous materials or hazardous substances. However, we want, as a people, we want to live in clean environment. We want to be healthy, right? So this causes that we should manage our waste properly, and also we have knowledge how to manage our waste properly. Solutions actually may be closing the loop of our materials, of our products. And one of the solutions is the concept of 4 R's, so reduce, reuse, recycle, and recover. Example of the number of papers which are related to 4 keywords: recycle, reuse, reduce, and recovery. And you may see that the number of papers increases during the time, so it means that the scientific interest in that field is also growing. And how to achieve the goals of the European Union, and how to implement the reduce, reuse, recycle, recovery concept. Actually, we should have the very efficient system of waste collection, right? So maybe, yes, so we should have the separate collection. Maybe you recognize this bins actually because this picture was taken in Covilhã in Portugal. So maybe we should have some bins equipped with some pressing system to increase the volume of the bin. Maybe we should have some smart bins which knows what is inside and which knows how much of waste is inside. So maybe like here ultrasound level sensor, or maybe other sensor also can be used. The waste management goals, zero waste or circular economy, actually we should pay attention on education, because people, they will do the job, right? So that they will separately collect waste, and they should know the reason, they should know how to do that, and they should know what kind of effects may be expected from their activity. Efficient system of waste transportation, right? So 100 years ago it was just some let's say manual transportation system. Right now we have very advanced multi-task trucks which can work with different types of bins. Also those trucks may be equipped with a GPS systems for the optimization of routes. So efficient system of waste sorting, right? So this is the picture from about 20 years ago in Poland. Right now we have such kind of manual separation or sorting plants. However, most of the mechanical and biological treatment plants in Poland, right now they are implementing the optic separators, so automatic sorting systems. So this is the development, right? So here we have 90% of the efficiency of that kind of sorter. Here we have 10%. Here we have just a couple of percents of the efficiency. So there's a big jump in the efficiency. Going back to the money, to the costs, we should be aware of that if we want to increase the recycling efficiency, so for sure the costs will be higher and higher and higher. So somehow someone must find the money for the covering all of these costs of the waste, efficient waste management. Right, so this is kind of a new approach, right? New approach, closing the loop. So this previous one, linear approach, was not efficient enough to fulfill or even give a chance to fulfill the goals of the European Union in waste management, right? So the circular approach may be a solution. And we may say that the traditional system engineering approach provide a general, they break down when they applied to systems so complex. And as I showed you, the waste management system is very complex. We have dozens of different aspects which could be included, and in the linear system or even multidisciplinary system may be not good enough to solve the problem. So we should look for other approaches like interdisciplinary or even transdisciplinary approaches to solving the waste management system. And closing the loop about the interest of scientists and researchers. So I checked the number of papers when I use this closed loop supply chain. So you may see that there's the growing number of the papers dealing with that topic. So one of the newest waste management principle, upcycling, it's a kind of trend in the creative treatment of waste that produces products with a value higher than the new raw material processed. This process reduces both the amount of waste and the amount of material used in the primary production. And also I checked the number of papers, and also there is a growing number within the last couple of years. So it means that upcycling as a principle also is getting interest. We have a zero waste, so design and management of products and processes in such a way as to avoid to eliminate waste as much as possible and to promote the saving and recovery of all of resources. Also, there is a growing number of papers, so it's also one of the solutions which will be developed within the next couple of years. So I will skip slides because I need a time. I go to the conclusion. So actually, we may conclude that waste management is a complex system of strategies, technologies, techniques, expert people designed and combined to achieve either global and local scale problems under economic, environmental, and political influence. Also, we may conclude that waste management efficiency increased due to the transition from linear to circular approach, for sure. Also, we may say that the principle of 4 Rs, so reduce, reuse, recycle, and recover, was the main driving policy for last decades, especially in the European Union. New ambitious goals in the European Union to implement circular economy and zero waste strategies have been established, and we are aware of that. And to achieve these goals, current circular approach to waste management may be not efficient enough. We may say that one of the solutions may be brought by the transition to the transdisciplinary approach. So the connection of all of the sub-systemic solutions implemented at different levels, like at home, business, and cities. Like we may implement together parallelly 4 Rs principle. We may think about the Internet of Things. We may also apply the artificial intelligence, machine learning, data mining for the improvement of the waste management. Of course, the approach of closing the loop, upcycling. However, also urban mining. So we may consider a city as a source of the resources. We may implement the concept of smart cities when we implement the tools given by the new sensors, new information techniques. We may have some kind of smart packaging, smart bins, and other unknown yet solutions. The last conclusion, which may be derived, that for sure now we have not implemented the zero waste approach into the practice yet. However, the last statement of this presentation, so however, the development of the new technologies and approaches may transit to zero waste approach from utopia to reality. Sorry for the prolongation a little bit. However, I hope that that speech was interesting for you. And the first slide, I included my contacts. There is an email, there is a phone number if you want to touch me. So please don't hesitate. So thank you and have a good conference. See you. Thanks.
Good afternoon, everyone. My name is André Studart, and I'm here to present the chemical and mineralogical characterization of biomass ashes for soil reinforcement and liner material, which is an article that I developed with Leonardo Marchiori, Maria Vitória Moraes, Antônio Albuquerque, Pedro Gabriel Almeida, and Victor Cavalheiro, all of which have ongoing studies here at UB, Universidade da Beira Interior, located in Portugal. And so, to begin this presentation, I would like to speak a little bit about the necessity of investigating the backgrounds of soils and residues that could provide not only a large understanding, but also potentializing their possible integration. For example, if we decide to investigate to fully understand a soil, we would have to look at the geological, physical, and chemical processes that occur where it was firstly collected. These processes will have profound effects on the general characteristics of the soils, such as plasticity levels, geotechnical parameters, and as well the resistance parameters. So, if we do this to fully understand a soil, why shouldn't we do this to also fully understand a residue that's causing problems, sustainable problems, and disposal issues? And this is why we decided to do this, but with biomass ash, which is the product of thermoelectrical facilities for energy production, not only because they are widely produced, but also because they could imply on soils and underground water contaminations due to the several taken processes at thermoelectrical facilities, as we are going to see forward in these presentations. And so, we decided to collect the biomass from Grupo Razão in Castelo Branco from Valam Company, where the soil was also collected in Castelo Branco. We wanted to evaluate them chemically and physically speaking, so we could check their background analysis and feasibility for further research of valorization applications, in this case soil reinforcement and liners application. Beginning with the results and discussion, after the taken tests, we could state that the soil has not only a whitish color and a silty sand granulometry, but also has a 10% clay portion, an optimum drying weight of 1.92 grams per cubic centimeter, associated to optimum water content of 19.40%. Whereas the biomass has a darker color, a finer silty granulometry, and it's associated to an optimal dry unit weight of 1.12 grams per cubic centimeter with 25.80% of optimum water content. And this attracted our attention because the biomass granulometry characteristics could actually indicate possible weight reductions while filling voids within the soil, as it has a finer granulometry and a lower dry unit weight in general. And when we proceed to the FRX analysis, further the FRX analysis, and here is presented the concentration levels for both soils and the analyzed biomass ash. And firstly, I would like to attract attention for the high TR of silica, aluminum, and ferric content on both soil and biomass ash. Their sum would be close to 75%, which is the minimum percentage according to US standards to induce a pozzolanic reaction. So this might be a possibility here, and its benefits as well of having a pozzolanic reaction within a possible mixture between them. But the other thing that I would also like to attract attention on the negative side for the biomass ash are the arsenic and cadmium concentration levels, as they wouldn't pass the current regulatory limits according to Poland's and US legislations, for example. Although this is very important and negative, it's also important to reinforce the necessity of evaluating leachability levels of these compositions. Let's say, for example, if it is stabilized inside the sample, if there is no leachability, if it's not leachable, then it's not exactly a problem because it's being isolated inside the samples. But we have to make sure, we have to assure that it's not going to be leachable and it's not going to cause any contaminations of soils and waters itself. Even though, let's say for example, if we have low introduction rates, as low as 5, 10% or even 15%, the concentration levels within these mixtures might be low enough to be even lower than these legislations across Europe or even America as well. So this is one possibility, and further research is necessary in this case. And proceeding for the DRX analysis, we can state that the soil has a quartz, muscovite, and kaolinite clay portion, which basically is very related to Castelos Brancos region, that is mainly based on K feldspars, granites, and schists. And the same the same happens for the biomass ash, although this time they have one slight difference. They have some minerals, such as calcite, that are not so easily explainable by Castelos Brancos region, which means that in this case, the region itself, the geological process, they do not explain totally what happened to this material here. And let's say, for example, the profile of the biomass ash is highly crystalline. In fact, so much that it's hard to explain. For example, if we look at the biomass ash profile here analyzed, we can see many peaks that are not easily explained by the previous presenter table. But these very same peaks, they represent a crystalline structure that's basically new. And we interfere that they are new because they are not easily found on Castelos Brancos region. Therefore, we could also interfere that they were appearing after the several taken processes at the thermoelectrical facilities, which were basically transforming, chemically and physically speaking, the original biomass into a new material. And not only because of the high temperatures used, which were from 500 up to 1400 Celsius degrees, but also because of the used char, because the iteration between char, biomass, and high temperatures was basically creating a totally new material, because the enrichment of minerals were happening and the disintegration of other minerals were also happening, which is the case with calcites. Calcites were being disintegrated into lime and carbon dioxide. So this is one example of enrichment process that was occurring at thermoelectrical facilities. And we could trace this back principally because of the Castelos Brancos region, the soil type, and basically also the type of vegetation that's there, which is mainly pines, because if we cross data from pines with the analyzed biomass ash, we can see many similarities. Therefore, we could conclude that this combustion process was basically creating a new material compared to the original biomass. And this leads us to the conclusions. Being the first one, the fact that the biomass ash is basically a new material compared to the original biomass because it has suffered too many physical, chemical alterations, being very hard to trace exact patterns of what happened and what has not happen, principally because of the numerous anthropogenic interference and natural conditions variability. But even though we were able to link it back to the original biomass vegetations, which were pines, and define it as aluminum silicate material, which is that's also linked to the type of used char during its combustion, because even the type of char will react differently with the biomass and providing and enriching different oxides and minerals itself. Another conclusion was the fact that possible void filling, weight reduction, and pozzolanic properties are achievable through its fine CLT granulometry and high silica, ferric, and aluminum content, which have yet to be confirmed with further research. And for the last point, we could also state the presence of heavy metals among the biomass ash composition, contraring biomass general sustainable belief. And this leads principally to the necessity of evaluating leachability levels and concentrations on low introduction rates to check if these concentration levels will be enough to attain the current regulatory limit, and if we are going to be able to stabilize this residue into a soil with further reinforcement and possibly liners application, which have yet to be confirmed with further resistance testing through triaxial tests and so on. But for now, the initial results are very satisfying, and this research has been able to define some major bullet points for the biomass ashes, which were the ones that I just described here. And with that, I finished this presentation, leaving my contact here in case you want to know or any specific information or have any doubts of what was presented here. And I would also like to acknowledge the FCT, FibEnTech, Egeo Biotech, and João Dia das Neves for making this presentation and work to be possible. Thank you very much. If you need something, I'm here. You can always contact me. Thank you.
Hi, my name is Leonardo Marchiori, and I'm going to present the paper about geotechnical characterization of biomass ashes for soil reinforcement and liner material, developed at TUBE with the FibEnTech and GeoBiotech support. Biomass ashes are the byproduct produced mostly in coal-fired thermoelectrical facilities for energy production. Several processes are involved in these facilities, such as combustion, pyrolysis, and incineration, generating biomass ashes, which are considerably different from the original biomass. Biomass ashes waste has received attention due to its possible pozzolanic properties for the cementitious industry, and for the possibility of the recovery of valuable chemical components, and it seems to have low hydraulic conductivity when properly compacted. So this paper aims to investigate and characterize biomass pine ashes, geotechnically searching for its feasibility for soil reinforcements and an alternative liner material. The same methodology was applied to both materials, one for the soil and for the biomass ashes, following the laser granulometry through COTAR-LS equipment, and geotechnical parameters were evaluated through European standards for specific gravity, Atterberg limits, and the normal proctor compaction. The granulometry distributions are presented as we can see, biomass ashes, the orange curve, have finer granulometry than the soil analyzed, the green curve. Biomass ashes show with about 20% of clay and the soil around 10%. It can indicate filling properties for biomass ashes incorporation in soils. This table resumes the geotechnical parameters of this work, and the soil showed 2.7 of specific gravity, and the biomass hash is 1.9, much lower, indicating a possible weight reduction for a future mixture. Other authors found values around 1.7 and 2.5 for this parameter. The soil analyzed is a low plasticity soil with only 4% of plastic index, and the biomass had no workability to make the consistency limits tests, so it is considered a non-plastic material. Other authors found very different values according to the biomass culture, showing values of non-plastic materials to materials with medium to high plasticity, around 10 to 16% of plasticity index. Compaction tests were obtained with normal energy compaction, and the soil presented 20% of optimal water content, lower than the biomass hash, 26%. It was already expected with biomass finer granulometry, and for the dry specific density, the biomass hash showed 1.2 grams per centimeter cubic, much lower than the soil, 1.9 grams per centimeter cubic, corroborating with the weight reduction indicated for the specific gravity showed before. As for the plasticity values, authors already found very different values when using different biomass hashes types, showed at the table. So the work we are still developing, the main objective is to incorporate biomass hashes into soils with several ratios, different ratios, to analyze its mechanical and hydraulic performance, searching for soil reinforcements and an alternative liner material. The proposed percentages were 5, 10, 15 and 20% of biomasses in the composite material, always considering its dry mass into the mixture. Similar works around biomass hashes found cohesion values around 20 to 25 kPa, and for the friction angle, values around 30 to 45 degrees. And sometimes other works can achieve the minimum for a geological barrier of 10 to minus 9 meters per second of hydraulic conductivity. Our conclusions in this work were that the biomass hashes are highly variable and dependent on the species, its origin, and the combustion process in the thermoelectrical plants, needing almost an individual evaluation of its parameters. There are lacks of investigations around its mechanical resistance, its hydraulic performance, and the long-term behavior of this material. But the biomass seems to contribute with filling properties, a decrease of plasticity, possibly stabilizing weak soils, and a possible weight reduction of the future material. Thank you for your attention. This is a work that we are still developing, so many parameters and other new parameters are going to be presented in the future. And I would like to thank FibEnTech Congress for the opportunity and the other co-authors of this work. This is my contact email for any doubts and questions, and I'm always available. Thank you very much.
Hi, my name is Vanessa. This topic was the subject of study in my master's, and it's about the evaluation of Entre os Rios thermal aquifer vulnerability using drastic index. So, this research is related to the topic of an oil spill that began in subterranean tanks at a closed fuel filling station. So, the presentation will follow the following order: abstract, introduction, material and methods, results and discussion, conclusion, acknowledgements, and reference. Considering the subject of investigation, it is important to remark that the Entre os Rios thermal aquifer has protection parameter for avoiding water contamination. A vulnerability map was generated using geographic information systems tools and the drastic index, and the results showed that the perimeter has insignificant to moderate risk to pollution. So, to begin, it is significant to mention that Portugal has a high ecological heritage value in abundance of natural mineral and spring waters. Portuguese legislation established protection perimeters based on parameters that support a sustainable exploration of resource. It is possible to see the three different zones in Figure 1: immediate, closed, and distant zone. By establishing a protection perimeter, the risk of groundwater contamination is reduced. If a pollution event occurs, corrective action is taken instantly so that the water reaches the catchment with acceptable levels of pollutants. So, the aquifer's vulnerability to pollution is determined by the continuous and diffuse pollutant loads that put pressure on its perimeters as well as its intrinsic characteristics. The intrinsic vulnerability is determined by the aquifer's hydrogeological characteristics. So the specific vulnerability includes a few outside variables, like land occupation, source of contamination. Aquifers with a high vulnerability may have a low pollution risk, and aquifers with a high pollution risk exist despite their low vulnerability. So the study of the groundwater vulnerability allows the identification of areas with the highest potential for contamination. In the drastic methodology, each parameter is subdivided into representative classes, which are assigned an index ranging from 1, 10, and 10 in order to correspond with the local hydrogeological characteristics. The product of these values by a relative weight of each parameter gives the value of the drastic index. The geological profile presents that are the microgranite veins installed through the area within the granite masses that influences the emergence of water. The conceptual hydrogeological model distinguishes the following aquifer systems. At the surface, a highly altered and decomposed free aquifer that represents a critical role in the recharge of the underlying aquifers. A free to semi-confined aquifer with normal water circulation in altered zones and in most granitic feature zones. A confined mineral aquifer located in depth and conditioned by a zone of structural weakness. The AC2 is located in granitic rock near a contact with granodiorites. So the maps show the location, the Barbados Well, and the mineral spring waters in the Douro River basin, the model digital terrain of the study area, and the map of the geographical location of the Barbados Well and the protection zones and their conditions. So the parameter D was calculated using piezometric measurements from a set of 36 georeferenced water points. To interpolate the depth of the aquifer stop was applied the inverse distance height weight method, resulting in mean values of less than 4 meters, corresponding to an index 9, indicating that it is a very sensitive attribute. The anion of slope areas less or equal to 6%, curvature profiles less than or equal to 0, and areas that allow infiltration forms the map of infiltration potential zones. A recharge of 40 millimeters per year was assumed using the precipitation values, resulting in an index value of 1 for the parent parameter R. So the parameters A and I assumed prevalence of 2 and 3, which are features of magnetic rocks in the research area. The attribution of greater susceptibility to microgranite outcrops is conscious because fissural percolation can endanger the aquifer. The parameter S was calculated using the COS 2018. Forest soil, as well as temporary crops and bushes, are more likely to be affected by pollution. The parameter T was obtained by considering the model digital terrain and slopes map. The parameter C was created using an abacus that related representative values of hydraulic conductivity for various types of rock. So in the table 1, it enables us to confirm the drastic index values range from 47 to 127 points, ranging from insignificant to moderate for normal pollutants. It is possible to observe the slope map, the map of areas with higher susceptibility to pollution, and map of the Entre Rios aquifers pollution vulnerability within drastic methodology. The areas occupied by microgranites and where meteoric water infiltrates along preferential recharge sectors, hydraulically light to deep fracturing represent a moderate vulnerability. So the use of several approach to define protection perimeters allows for the long-term preservation of the quality of the hydromineral resource. For the immediate area, a radius of 50 meters is proposed, with the center of the circle representing the mineral water catchment. Is justified by the fact that is an aquifer system whose lithological support is made up of igneous formations that range in alteration from highly altered to little altered. The closed area is defined by geological, structural, hydrogeological, and pollution vulnerability parameters. Its purpose is to protect the use of direct interference on the local emergency mechanism. The limits of the distant protection area were established to include preferred recharge sectors that are hydraulically related to deep fracture. The purpose of this area is to prevent contamination zones from developing, preventing further surface runoff and subsurface pollution. For the conclusion, the vulnerability map shows that the protection perimeter area has a low vulnerability to pollution, which is partly related to the geological characteristics of the region, which tend to prevent polluting compounds from infiltrating. Despite the fact that areas are oversized, it is important to consider the heterogeneity of the underground environment in the study area, the possibility of preferential flow-through fractures to areas surrounding the catchment, and the uncertainty associated with method application due to the indeterminacy of some hydraulic parameters. So we are grateful to the FCT Portugal for financial support by national funds through the projects of the FibEnTech and GeoBiotech. So this presentation made use of the following bibliographic reference. And for finish, we hope to visit the thermal complex of Entre Rios. Thank you for your attention.
Well, we are back, and what a nice final with this nice view of Entre Rios thermal place. So thank you very much for presentations, high quality presentations, and I welcome this minutes of discussion period to Vanessa, Leonardo, and Andre, the young researchers that the more recent results of your report. So I just picked up some questions of your words from my email, and I will put these questions first to Andre. So Andre, I have here a question that is about some of these wastes that you are using can bring worries on their hazard potential when you mix it with soil. It is understandable. How can you control the potential in leaching some kind of pollutants, such as heavy metals or nitrogen, to groundwater? I think it's a question that you probably mentioned in your last paragraph of your conclusions, but probably it arrives early in your presentation, Andres.
Yes. Okay, so to respond this question, we would have to assess firstly what the heavy metals would be and which components would actually be leachable from the residue that we are working with. And we would have to make leachability tests to assess how much of it is actually being leachable and how we would stabilize it. So we already know that there are within the nature some components that we can introduce along the soil and with the residue to stabilize these components. And this is why it's so important. Because the residue itself, as we have seen, they have some heavy metals that sometimes are higher than the regulatory limits.
Sorry to interrupt, Andres. Do you know already which are the heavy metals?
Yes, we do know. Arsenic, for example, cadmium, copper as well are some of them. Some of these, for example, they don't respond to the actual regulatory limits, but these actually depend as well on the countries that we are working. So, for example, it could be that this residue pass in one country and not the other one. And in this case of not passing, we would have to make some assessments and leachability tests to assure that this quantity would pass. Because let's say if 100% of the residue doesn't pass, maybe 5% or 10% is okay. So this is the test that we would have to do.
Okay, Andre, thank you very much. So next question is for Leonardo. Leonardo, how will you create the liner? By compacting the mix of waste and soil? And what are the thickness of the material? Are these liner material cost competitive compared with the clays or geomembrane that are the current material using for protection the water, groundwater, and soil with this kind of hard work?
Yes. First, we are going to use the percentage that I mentioned in the presentation, 5, 10, 15, or 20%. Then with the results of the mechanical resistance, mainly the triaxial and odometric results, we're going to choose 2 or 3 to test its permeability. With the best material in hydraulic parameters, we will try it as the liner. And as we are developing a new material incorporating residues, we can substitute the clay material, there is an expensive raw material, or even the geosynthetic material if the parameters are quite well for liner barrier. So it will decrease the costs, and probably this is a competitive future material. Yes.
Thank you, Leonardo. So now next question is for Vanessa. So Vanessa, actually there are two questions. So the first one is why did you build MDT model? So I think is the Terran model. And what could happen if the study had given a high risk of pollution? So we understand that your work
Yes.
has given a low level of risk for so the vulnerability is low. But what could happen if the study had given a different results, high vulnerability?
Okay. DMT is for it's the first step to create the region of a area in three dimensions, so we can understand how the waters run to the aquifer, and if the risk of pollution is higher, we can increase the areas of protections. So we can increase the closed zone and the other zones. So in this case, after we the pollution risk is not very high, but the areas of protections are increased because of the geological region. It's very so the drastic index are used three parameters that are related with geological parameters, and these parameters are attribute an index, and if I use the three parameters related with the geological parameters in my case of study, so it's not of course the vulnerability it cannot show the correct, because the drastic index is not it's not so conclusion. I don't know if I
was clear your answer. Thank you very much. So last round of questions for Andre. Andre, how can you define the optimal waste-soil ratio for soil reinforcement?
Okay, so that answer would depend on the residue that we are working with. So, for example, there are tons of works already published in the literature, in the internet as well. So, if we are working with biomass ash or water treatment sludge or even other residues, we can basically check on Google Scholar and among other platforms to see how similar the analyzed residue is to the one that we are studying. And if it's similar enough, that would be a good starting point. So, for example, lots of studies for biomass ashes say about in between 10 to 20% of introduction into soils for the optimal range. So we decided to start at this range to investigate the optimal introduction rate. So we decided to start in 5% until 20%. And with that, we do believe that we can have a good range to investigate the optimal introduction range, and principally to have other mixtures as well, so we can compare with the optimal one. So that's the idea. But the starting point would definitely be based on the already published studies.
Thank you, Andre, and welcome to this section. Second question for Leonardo. Leonardo, how can you control the optimal thickness of the liner in order to not break it? So that means the mixture between the soil and the waste without have a break in the liner. I think is what is asked here.
We should compact it with the normal parameters, the normal Proctor parameters. Sorry, we use the optimal water content and the optimum dry weight, unit weight, to minimize the voids in the soil.
Sorry, I understand the question of this question because I'm thinking whilst you are talking that if you use this liner for example, in landfill, a sanitary landfill, so you can have 10 meters, 15 meters of wastes, and so that means that it can break this liner if it's not
okay. That's why we should do mechanical tests. We will do the triaxial to see the cohesion and friction angle. As a slope, we will search for the slope stability to use in landfills and other geological barriers. And as well the odometric, that it can show us the differential settlement that the whole liner will have with the load upon it. So it can control the material mechanically and also hydraulic for these applications.
Thank you. Now the last question is for Vanessa. Is last question of this session. Vanessa, what is the advantage of using GIS with water quality or water vulnerability models? So why you use GIS? That is a model that deal with the amount of information with other models of water quality. In this case, is for creating a water vulnerability map.
Okay, the GIS permit us to combine a lot of that information, and with that data we can interpolate and we can create a lot of functions with all the parameters. And I'm using the drastic index, but I can use the other ones. I just choose that because it's the index. The drastic index is the is the method that used a lot of parameters. The other ones used a lot of few parameters. So the drastic we can use a lot of information and permit us to with the raster information and the pixel information, we can proceed to calculate a lot of functions. So that is the most important thing for us to use GIS information systems tools in these works of vulnerability in water systems.
So it was very clear, Vanessa. So you can deal with the big amount of information that normally we use on the desk to show and to look at some kind of relationship, and you use this kind of software GIS that can deal with these and then can make a lot of operation and can give you some easily way of look at the vulnerability. Thank you very much, Vanessa. Thank you, researchers. And now we close this seventh section of the Congress, and in a few minutes you'll have the closing section with the Professor Arlindo Gomes, the chair, and also Professor Paulo Fiadeiro, that is the scientific coordinator of the FibEnTech Thank you very much, and good afternoon.
Good afternoon, everybody. Welcome back again for this final stage of our Congress. First of all, I would like to greet and thank the participants that attended our first International FibEnTech Congress 2021 on new opportunities for fiber materials and in the ecological transition. A deserved acknowledgement also to the invited speakers and to all the speakers who have submitted and presented to us their research achievements, which are all in the scope of this Congress. Looking at the topics of the Congress and the topics that were discussed here during these 2 days in the different technical sessions, it was clearly demonstrated the great interest, commitment, and motivation of the senior and junior researchers about the problems and concerns raised by the well-known and necessary ecological transition. Fibrous materials, their characterization and functionalization, and the corresponding new products that can be produced are in fact a great challenge to us. The understanding of the impact of the related research and the innovations in our lives, health, and in our planet are crucial and emergent. Also, I should mention the interesting proposed sustainable alternatives for the organic matter and pollutes removal, for the treatment and recycling of urban, agriculture, and industrial waste and water waste. For that reasons, I'm very glad to realize that our FibEnTech Congress gave an important and relevant contribution for that purpose in which we were all involved. I congratulate all the speakers for the excellent presentations, and I encourage everybody to pursue on the research path outlined, as I am sure that we are acting accordingly. Thank you, all of you, and the organization committee for the Congress. Now, I'm going to pass the word to the chair of the Congress, Professor Arlindo Gomes, to officially close the Congress and the working sessions. Thank you very much.
Hello again. I am back after the very nice words from Professor Paulo Fiadeiro, our leader at the FibEnTech. As chair of the conference, I opened the first session, and now at the closing session of the first international conference of FibEnTech, I will say a few words and presented some data. The conference included 32 communications from participants and 3 communications from invited speakers with extensive curriculum in the subjects of the conference. The best of the research from high educational and scientific institutions from Portugal and abroad was presented and discussed. In many cases, the conference was the first opportunity for actual and future master's and PhD students perform presentations and answer questions in an environment respecting the actual constraints resulted from the COVID-19 pandemic. We were right to rely on computers, internet, and in Nuno and Tiago from within the Grove presentations and discussions occurred smoothly as planned. So, in my opinion, the first international conference from FibEnTech was a success, with minor details to be corrected by the organizing committee of the second international conference. At the opening session, I raised two questions: why we are here and why we should care. At the end of the conference, I may conclude that we were here because we had scientific work to report and to discuss, and certainly we are concerned and working to contribute to an overall sustainability of our planet. The work of the organizing committee is not yet finished. It will be finished after the review of all the publications, papers, and posters, and only then we will be without job. To finish the conference, I wish all a Merry Christmas and a Happy New Year. Goodbye, and I hope to see you all next time. Thank you very much.